All right, why don't we make the drawbox right dang now then? So we've talked about inheritance. The class you extend, that's the Java term, the class that you inherit from is called the superclass. Also known in some books and some disciplines as the parent class or the root class. So person is the superclass to customer. Person is the superclass to employee. Employee is the subclass to person. Customer is the subclass to a person. And a class can both be a superclass and a subclass. Employee is a subclass to person, but it's also a superclass to these things. And if you do polymorphism right, and I'm kind of jumping ahead a little bit ahead of the lectures, then you could make code that would be able to handle both customers and full-times and part-times that you call the same code, like a display method. And it behaves differently based on what kind of data is sent to it. But when I say differently, I don't mean dramatically differently. It's just that it handles the parts that are unique. A customer has an address, but it doesn't have a salary. You know, a full-time employee has a salary, but doesn't have an hourly wage. And, you know, a part-timer has an hourly wage, but not a salary. And so when you're printing this stuff out, or if you're popping up, you know, a user interface so that you can let the user enter different bits of data, then it could behave differently. So benefits of inheritance. It helps with code reusability. The superclass code can be used for multiple subclasses. Eliminates code redundancy, meaning that if you have a lot of shared information in this person class, you can put a lot of the logic in there and then just put the specific stuff that modifies the person class. In a video game, you might create a fighter class, and then you might subclass that, you know, into a paladin class versus, tank, the tank class, whatever. I don't know the modern terms for this. I know old D&D terms or whatever. So then lot of common stuff between a paladin and a regular fighter. And so they both could inherit from the same thing, but each one has their own special abilities. So they say that a programmer can use an existing class to easily create a new subclass. If we wanted to, we could come up with a new version of the string class. We would merely extend the string class and then modify it. I cannot imagine what else we would want to do with the string class. It's pretty powerful as is. But if you could think of some functionality, you wouldn't have to write necessarily a method that handles that functionality and then copy that method from one project to another whenever you need it. You could extend that string class, and then whenever you need it, you bring your own subclass into the project and you could use it. So their example is that the person class has a name, has some constructors, and has a getName accessor method, has a getter. The employee class inherits the person's class members, also has an ID instance member, any necessary constructors to handle that ID, and to have a display method. And they give an example of that. I think that we ought to do an example of that as well. So something to know about the private keyword is that private means that data is protected not only from the client class, but even from subclasses. There is a different keyword that means my subclasses can access me, and that is protected. Time to start making notes. So public members can be accessed from client code and from subclasses. Private members can only be accessed from within that class, not client code or subclasses. protected members can be accessed by subclasses, but not the client code. So in real world terms, if you have a person class and it has a name which is private, and you provide a public, getter and setter for it, then if you have another class, and I should be naming all my classes, with uppercase letters, you have an employee class and it needs to access that name, it's going to have to use the public and getter and setter. But if you want, you could make a member protected. Age. So to have to use the public getter and setter for name, because it's private, but can have direct access to age. Now the way my brain works, I'm not going to even talk about that. I could see an argument for making all your variables protected rather than private if you thought that the subclasses ought to have complete access to the parent class. But if you want to strictly control the way that data is accessed, like you do not want the even the employee class to be able to set the name to something invalid, then you would want to force them to use the person's class, getter and setter, in order to access them, in which case you would indeed make it private. So even though a superclass's private instance variables are not directly accessible from a subclass, they are still supposedly inherited by the subclass. You just can't see them. You can't access them. They're still there. That's kind of an odd point. So if you need to call the superclass's constructor, there's a keyword that does that, super. And then you pass in any arguments that you need to into the constructor. It's about time for us to play with classes, I think. So I'm going to go ahead and launch NetBeans. And the primary illustration of this first class that we extend is just going to be showing how the constructor can be invoked if you need to pass in data into a constructor of a superclass. So I'm going to make a new project, April 5. And I'm going to be a terrible person and put all of my classes in the same file. And just remember, when you become a professional, you can look back at your professor and think he was an idiot because you know better. But you also know why I do it this way. Okay, so I'm going to create a class called Animal. And all we know about the animal is that it has a name. So private string name. And we're going to create a constructor for it. String should be capitalized. So public animal that takes string for a name, and it's going to set this dot. I don't know why I made that variable uppercase. Name should have been in lowercase. I'm being real sloppy, and my uppercases and lowercases. This dot name is equal to the name that's passed in. And again, I goofed with my uppercase, lowercase. This dot name, all lowercases. Okay, so we have an itty-bitty little class here. Now I'm going to make a class that inherits that. Why are you yelling at me? Field name can be final. Final means that once created, that string will never change. And sure enough, that's true. And it's pretty sneaky of the compiler to examine the code that carefully and to notice that nothing ever allows that name to be changed once the object is created. But I'm not going to mark it as final because I just have to remove that if I provide a setter, you know, for that. Okay, so I'm going to make a class called monster that extends animal. And it's complaining that we don't have anything that can construct an animal. So I'm going to make a constructor for the monster class. The monster class has something different in it. Private, string, it's got a superpower. Monsters have superpowers as well as names. So now let's make a constructor for the monster. Public monster, and it's going to take two things. A name and a string superpower. And we need to call the root classes, the superclasses constructor, and pass the name in. Now why can't we pass the superpower in as well? Because this constructor does not accept a superpower. So we're going to have to set that separately within the subclass. So we call the superclass's name, the superclass's constructor in order to set the name, but then we have to set this dot superpower equal to the superpower string that's being passed in. And you can chain them like that. We could extend the animal class with another class that calls the monsters. We could extend the monsters class with another kind of class that calls the monsters constructor, which calls the animals constructor. Now what if we don't provide customized constructors, parameterized constructors? Can we get away with not having to call super? And the answer to that is yes. I'm not going to demonstrate it, but if we had made these classes without a parameterized constructor, a super, custom constructor like that, I would not have had to add one here and put a call to super here. It would just get invoked anyway. We could kind of prove that, but I'm not gonna take the time to do that. So do remember that you can invoke the superclass's constructor. All right. Let's make a couple of different monster classes, subclasses. Class, I don't know, vampire extends monster. And again, it's complaining that we're not calling the constructor. So let's just make it a little wimpy constructor. Doesn't even accept any parameters. I guess we could accept the name. Let's do that. Okay, so public vampire. We're going to accept the name of the vampire, but we know what his superpowers are. What is it? Sucking blood, flight, turning invisible? We'll come up with one. And so in order to get that to work, we're going to have to call the super, pass in the name, and as far as his superpower is, we're going to say that he can turn invisible. Now we ought to provide two string methods for these things, and we also ought to make these things protected, in my opinion, rather than private, unless there was a reason to make them private. But I am going to come back and add a two-string method to the vampire class and to the whatever other monster we create. And so for that to work, I'm either going to have to add getters for these things, or I'm going to have to make them protected. Because otherwise, how am I going to get the superpower when I want to call, two-string here? And how am I going to get the name? So I'm just going to highlight that guy and totally cheat and let refactor handle adding the getters and the setters. This is lame, but okay. I highlight that, I choose refactor, encapsulate fields, and if you feel like pausing the recording and typing in the getter and setter all by yourself, that's totally cool. You might not be using NetBeans. Encapsulate fields, and yes, I do want a getter and a setter for the name string. So I'm going to click refactor. Now I do have a getter and a setter for it. And it fluffed it out with a whole bunch of Javadoc comments that I'm going to delete.
You want us to do that only for the animal class?
Do it for do it for the monster class as well. Alright, and I like for my variables to be listed above the getter and the setter, so I moved name up to the top. Do you have to do that? No. Alright, I'm also going to do that to superpower. Refactor, encapsulate fields, give me a getter and a setter, please. Click refactor, and I'm going to again do the same thing. I'm going to delete the comments, make the getter and setters occupy only one line of code. Do you have to do this? No, you don't. And then lastly, I'm going to move the variable declaration above the getter and the setter. All right, that way, when we want to create a toString, we can do that. We can access those values. So we may as well do that. We're going to override the vampire's toString method. Have I gone too fast? Let me know. Slow me down. Okay, let me not rocket through this. Do you need to look at one of the bits of code, or do you just need to follow? All right.
So when you extend something, it doesn't automatically import those variables. You have to say super, and then.
It's not like this keyword, or you do automatically get those variables. And if I made them public, then I could use them in all the subclasses. If I made them protected, I could use them in all the subclasses. I made them private, which means they're still part of this thing, but you can't change their values. You can't access the values except through any, non-private methods.
In order not to see the error when you write class vampire extends monster, you have to declare super.
Right, right. If I don't do that, then it's going to complain that there is no default constructor. I could go and add a default constructor to animal, and I would never have to call super,
How's a default constructor different from the constructor that's already there?
Yes, a default constructor will not accept a parameter.
Okay.
And when you add a parameterized constructor, then it deletes the default constructor until you go back and add one yourself. That's why we don't have a default constructor available to us in the animal class, because we gave ourselves a parameterized one, a custom one. Okay, I feel like making one more kind of monster. Let's make Godzilla. We're going to have a vampire, Dracula versus Godzilla in the slugfest of the century. So class Godzilla extends monster. Let's make a good old constructor for him. Public Godzilla. Does he even need a name? Do we even need to pass in a name for him? I don't think so. Oh, I should not. I need to uncomment that line out. That was just to demonstrate the error. Okay. So I went back to my vampires constructor and uncommented that. All right. So when Godzilla calls the constructor, he's going to pass in both his name and his superpower, which is atomic breath. All right, lastly, we're going to put toString methods in them. Now, since toString does not really need to behave differently for vampires and Godzilla, the right place to put it would probably be in the monster class. Why do I say that? Because we don't need to customize toString. for vampires and Godzillas? How would it behave differently? Since these two classes don't have any data that differentiates them from each other, which is not really, so anyways. So I think I'm going to go and add toString just to the monster class, rather than add one to the vampire and the Godzilla and have it look exactly the same. So I'm going to go back up to monster, public string, toString. toString doesn't accept any arguments, so we don't need any parameters. And we're going to return string.format name colon %s super power colon %s, and then we need to fill in those values. So after my closing quote, comma, get name, parentheses, in parentheses, comma. I don't need to use get superpower, but I can. Why do I say I don't have to use get superpower? Because we're at the same level as that. I could do this. Okay, I should not have capitalized power. That's why that's there. All right, I got distracted by the error, but I could have just used this dot superpower because we're in the class in which it's defined. But I went ahead and I used the getter anyways, just so that it would look the same as that. All right, I'm going to compile this. I will scroll up and down and I'll make sure that everybody is caught up in here. Right now it doesn't do anything, right? Because we have not created a we have not added anything to our client. So we're not using these monsters. Okay, so scrolling back up from the top, pause as you need. That's our animal class. That's our monster class that inherits from animal. Kind of longs. That's everything except the constructor, and here's the constructor tacked on. The vampire class is very small because it doesn't actually add any data members. It just customizes the behavior of the constructor. We've just decided that every vampire has one power, which is to be invisible. And then we have Godzilla, which customizes the behavior of the constructor even further by specifying both the name and the superpower. All right. Anybody need any typo correction? Can you build it? We good? All right. So I'm going to go down to the client now. And let's create a Godzilla. Godzilla, big guy, is equal to new Godzilla. And then vampire, Dracula, is equal to new vampire. And let's give him a name, Count Dracula. And then let's just print both of those guys. So I'm going to add two system.out.print lines. Print Godzilla and then print Dracula. Or I could add them, to an array list. But I think this will prove the point. System.out.println, the big guy, and system.out.println, Dracula. So I run him, and what does he print out? His name is Godzilla, his superpower is atomic breath. His name is Count Dracula, and his superpower is being invisible. So we're well on our way to polymorphism at this point. We're demonstrating a little bit of polymorphism already, but we have always been able to call print on an object, right? And have it work, even if all it did is print the address of that object, the hashed address of it. because you didn't provide a toString method. So what we want to do now is provide a method that is available to both of those, but behaves differently, whether you call big guy or Dracula. And I think I'm going to kind of veer off and veer away from doing that, and I'm going to bring that idea back in when we talk about interfaces rather than talking about inheritance. You've already got the idea of inheritance. The subclass can have its own special abilities. You could add some methods to the subclass which you would not be able to access if you tried to call Vampire. You know, I could add a suck blood class, suck blood method to Vampire, and then if you had Godzilla, he wouldn't be able to do that. And I might add a stomp city method to Godzilla, and you would not be able to call that method on a Vampire. But anything that was defined inside a monster or animal, you would be able to invoke on either. Super has to be the top line of the constructor. So if you have a constructor and you want to call the, your superclass is your parent's class constructor, this has to be the first keyword, the first call in your constructor. So in an instance method, if you call a method that's in the superclass of the class, you don't need to use this dot. But you could. I skipped using this dot on getName and getSuperpower, but I could have. It would have worked if I'd done this dot getName and this dot superpower or getSuperpower. Now this one looks like it is a member of this class, right? Because our superpower is already part of the monster class. So it kind of makes sense. Well, I use this because it's a member of the, well, how is this a member of the monster class? It's because we inherited it from the animal class. To all intents and purposes, everything that's in the animal class, all the public or protected methods are also available to the monster class. What if you wanted to make a class that you could not instantiate? Could we change this to protected so that we could not create a monster? This is just an experiment on my part, and we're not going to mess with it very long. But if I make, no, not toString. If I make the constructor for monster protected, I've messed this up. I'm going to remove the this keywords because that messed everything up. Alrighty. Not that it messed it up, I just had typos. Okay, so this constructor is protected, meaning it can't be invoked from the client code. If I went down here and tried to create my own monster, monster M2 is equal to new monster, and he's got a name and a power, what, mummy, and whatever mummies like to do, gosh, I don't know, sit there and lie around. Okay, not going to let me do that. See, there I lied. Where is it getting this constructor? Let's go look. Probably because the monster class inherits from the animal class, which has a public constructor. Let's go see if that's true. I'm going to right-click on the monster class and do navigate, go to declaration, and it's going to show me the constructor for the monster class. But if I scroll up a little bit, animal also has a constructor. Alright, forget that. I am failing to understand how it is calling this constructor when it is public. I haven't spotted why that's the case. So, I'm not going to mess with it any further. But now we have a monster, and we could print him out too. I mean a generic monster that we did not create through a subclass. We just call that one's class rather than creating, using one of our two subclasses of the monster class. Method overriding, we've talked about that. It's when a subclass has the same name and the same parameter types as a method in its superclass. And we've been using overriding already. Every time we created a new toString method, we were overriding the toString method of the objects class. And here we overrode the constructor that we inherited from, the monster class. But it wasn't strictly an override because they did not have the same parameter list. Right, this one took a name but not a power, and this one didn't even take a name. So it's not a strict example of overriding. But I think y'all have the idea of overriding. We'll throw one in a little bit when we start talking about inheritance. But it's just when you replace a method in a superclass with your own. Dot equals is another one that we've overridden before, so that we can compare two objects. So if a subclass contains an overriding method, that's the one that gets called. It doesn't access the superclass's overridden method. We probably had better demonstrate that fairly quickly. Let's go ahead and do that. Nah, let's not do it. We'll get around to doing that in a little bit. Just accept that if I have a method here, let's go ahead and do it. Go back to the animal class, and we're going to make a method called move. So public void move. And all it does, and this is inside the animal class, is print system.out.println I am moving. And then we're going to go down to the Godzilla class, and we're going to add another method called move, which is going to be overriding the one in animal. Animal is the superclass to everything. It's the top one in the hierarchy. I could just copy and paste this. So I'm going to scroll down to Godzilla. And so public void move. And he's going to print out something different. System.out.print stomping along. That's how he moves. Now it's offering to add the override keyword. Nothing wrong with doing that. Add override @ with a capital O. And we've already talked about what that means. That tells the compiler that this method had actually be an overriding method. If we change it in some way so that it's not an honest override, like we put in a parameter there, then it's going to flag it as an error. Okay, so if I go down here and I move my mummy around, mummy.move, excuse me, he was called M2. M2.move, and then I move Godzilla. So big guy, this is down in our client code, big guy.move. Here's what we're going to see when we run it. The mummy said, I am moving. Godzilla said, stomping along. And that makes sense because that's the move method for Godzilla, which overrides the root method, which just said moving, because all animals, have that method of moving. Now we're going to do a wee bit of polymorphism, which is where we write a method that accepts any kind of animal, but its behavior is different based on what type it is. So I think I'm just going to put that as part of the main class. Public static void, and what are we going to call this method? Arrive. The monster's going to arrive. So what we're going to do is system.out, okay, he needs to take an animal as his parameter. So animal AN, whatever. And then we're going to print the animal out, system.out.println, the animal, and then when the animal's going to walk, excuse me, he's going to move, an.move. So then move down to the bottom of the code and do big guy dot, or arrive parentheses big guy, arrive parentheses Dracula, and arrive parentheses M2. So I'm going to scroll down here, and I think I'm going to comment out those two calls to move. They're kind of superfluous because the arrive method also calls .move. So arrive, big guy. I should have just called him Godzilla. That's a stupid name.
Animal.arrive?
No, because it's part of the client code. If you added it to animal, yes.
I only asked that because Neptune's automatically did that column.
I'll have to come look. Let me finish typing this and then I'll come look. So arrive big guy, arrive Dracula, and arrive the mummy, M2. And we will see that although these are differing types, they're being treated the same. We are able to pass all three of them into the arrive method. We're not having to write three different arrive methods, one to handle, Godzillas, one to handle vampires, and one to handle mummies or any other kind of animal, monster, whatever. We have written one method which handles anything that is inherited from the animal class, and the way it behaves is based on the behaviors of the subclasses. Specifically, Godzilla has a very customized move method. So when he moves, he said he's stomping.
This needs to be in the main class, not the animal class.
Correct. The move method needs to be part of the client class. And so Godzilla is stomping along, Dracula, it just says I am moving, and Mummy says I am moving. And if we overrode the move method for Dracula, we would see that happen as well. And I'm interested in doing that, so this will be the last change that I make before I walk over. Is that what you did? Did you put moving as part of animal? Okay, yeah. So this moving method has to be part, for this example to work, of the client class and not part of the animal class or anything's inherited from it. So we're going to go to the vampire class and also add a moving method. So I'm going to go to vampire, public void move. Again, it's an inherited class, so it's offering to add the, it's inherited, we're overriding an inherited method, so it's offering to add the override annotation, at override. And he's going to print that he's flying, because that's how Dracula's roll. That's how vampires move. All right, so when I ran him, we have our three different types. Godzilla is stomping, Dracula is flying, and the mummy just says I am moving because he doesn't have his own custom way of behaving. Why? Because we never defined a mummy class. So we just used the generic monster class, which inherited that message, I am moving, from the animal class. So this method here, arrive, is invoking different behaviors based on the data type without any additional coding on our part here. We're not having to say, is animal a monster? Which you can do. There's a keyword called type of. If an type of, and I'm probably butchering the syntax, vampire. Yep, I messed that up.
But basically, you're saving yourself from writing a huge conditional statement.
Exactly.
That would be really annoying.
I'm not going to mess with that any further. I don't know why it slipped my brain. But you could do, you know, if statements like this. If my object is a vampire, then do something else. If my object is a Godzilla, do something else. Else if my object, you know, stuff like that. We don't want to have to do that. It's bugging me that I don't remember how to do that, but I don't want to burn any time looking into that. But that's another way to provide polymorphism, but it's not an ideal way, right? You don't want to have to go and modify a method to add new if-else ifs just because you created new classes. So the final access modifier. Final means that it cannot be overridden with a new definition in a subclass. So if we have a method that we don't want replaced later on, we could mark it as final. Say we don't want to allow anybody to replace our constructor. We could mark that constructor as final. Or if we decided that for some reason nobody should be able to override the move method, then we would go and put, you know, public final move up in the animal class, and then we'd have to go and remove it from everything underneath it. Why would you ever use final? If you think your method is perfect, you might want to use final to prevent anyone from overriding it. Final methods might run a bit faster since the compiler can generate more efficient bytecode for them. Yeah. If you want to specify that a class itself cannot have any subclasses, then when you use the class keyword, you declare it as a final class. That just forbids anybody from extending that class. So if we'd done final class Godzilla, then nobody could extend the Godzilla class. So we have aggregation and composition. When one class is whole and the other classes are parts of that whole. This seems like a summary. An inheritance relationship is one class is a more detailed version of a class. That's called an ISA. Godzilla is a monster. The monster is an animal. The monster has a name. The monster has a superpower, right? So those are has-a relationships. That's composition. In the real world, it's fairly common to have aggregation, composition, and inheritance relationships in the same program. What sort of inheritance relationship could be added to our dealership program shown below? They don't tell us. All right, a manager and a salesperson could both be people, right? A manager and a salesperson could both be employees. You could make a vehicle class from which car extended in case you thought that there were going to be other dramatically different type of vehicles that this place sold. Card game program. All right, what I want to do is pause here from the lecture rather than, because you can read the card game program yourself. Got going on here.
Is that type of a JavaScript thing?
I am, pardon me?
The type of method you were looking for earlier.
Yeah, it's called instance of in Java. Thank you.
I only say that because it's right
Yeah.
up there.
Yeah, you triggered my memory. You're absolutely right. And here's the syntax for how to use instance of. If something is an instance of something else. So if I wanted to, I could go back to my arrive method, and I could do if the animal is an instance of whatever, not capital I, you know, the vampire class. then we can make him do something, whatever special behavior we wanted to do, for instance. That's another way to do polymorphism. But like I said, it's certainly not an ideal way, because then you have to go and modify every method that's going to exhibit behavior, you know, based on your instances of. This just checks to see if that class is a member, you know, this object is a member of that class. It's true. If you check the root class, right, then that would trigger as true for both all animals, all monsters, all Godzillas, and all, you know, vampires. But if we made this instance of monster, then if we made a root kind of animal, no, that would not be true. But anything that is a monster or derived from monster would be triggered by that.
We're just taking out that if statement, putting the animal A and saves on it.
Yeah, right. So I'm going to delete that. All right, where was I? All right, the block and cube assignment. Let's take a look at that. So here's UML for something called a block. It has 3 members. We would probably provide getters and setters for them, although this doesn't specify them. We have a constructor that sets the height, width, and depth of the cube. And then we have get volume and get surface area, and we have toString, and we have equals. And we know how to write those at this point. We know how to check to see if something is equal. We would check the height and the width and the depth, and if any one of those did not match, then it would return false. If they all matched, it would return true. So we're going to implement the block class. If you don't know the formulas for getting the volume, you know, and the surface area of a block, feel free to ask. I'll be happy to give them to you. Then we're going to extend the cube, the block class. The cube is going to have just one constructor. Well, I mean, the other one had just one constructor too, but just one parameter for the constructor because it has the same height, width, and depth. This is looking like a pretty lame assignment if that's the only difference between them. Okay, so then have your program create 2 blocks of different sizes and then print them out along with their volumes and their surface areas. Have your program create 2 cubes of different sizes and print them out. Have your program create a rectangle that has the same dimensions as one of your blocks. What? How about making that say cube? Have your program create a cube that has the same dimensions as one of your blocks. We need to reverse that, right? Create a block that has the same dimensions of your cube. So if your cube is a 3 by 3 by 3, then you will create a block that is 3 by 3 by 3, and then use dot equals to see if they match. Then use dot equal to see if it matches one of the other blocks of different dimensions. Hope that makes sense. That's not nearly as complicated as what we've done because the only behavior that is different is the constructors. So this should have been more complex, but I'm not going to pop, you know, rip out a different one right on the spot. Hopefully y'all are thinking about the piggy bank problem, and hopefully y'all are really thinking about your project. I hope y'all have looked at the projects. I think that we went over them, you know, before the spring break. If you want to do your own project, you better hurry up and come up with the idea and let me know about it. Some of these projects are more difficult than others. A lot of people just go for the simplest project, and that's fine. What could we do to make this more interesting? If we have a little bit of time. I can't think of anything that a cube has to have that's different than a block. That's what's bugging me about this. I can see why I didn't add any custom behavior to block. To cube that block didn't have. Quite often what I do is I also have an assignment where you create a root class called shape, and then you override several members of the shape class when you create a circle or a square. Let me see if I have that one already cooked up. Nope. Okay. So here's what that would look like. Create a class named shape that has a get area and a get perimeter method. Then create a class named triangle. I don't know how to get the perimeter of a triangle. I know 3D shapes better than 2D shapes. So this is going to be a 3D. So get area, it has two members, two methods. Get volume and get surface area. And then create a class called cube with pretty much all the members shown above. This is still not going to be differentiating between one and the other. Yeah, it will, because we have to calculate the volume and the surface area differently. Now, if we just have a generic shape, we don't know what get volume is supposed to do, right? So it's just going to return 0. I'll write this up in a better format after a little bit. So both of these are just going to return 0. And so the cube, you know, it's just going to have one value, side or edge. I'll make it a double. And a getter and setter for that, if you feel like making a constructor for it as well. And it will have its own overridden and override the get volume and get surface area methods to return the proper values. For example, get volume of a cube returns, you know, edge times edge times edge, right? And then another shape. So cube needs to extend shape, and so will the sphere class. It's going to have a different variable. Rather than edge, it's going to have one called radius. And again, you will override the get volume and the get surface areas to return the proper values. And that's not the formula for the volume. 4/3 times pi r cubed. I don't know. You'll look it up. You know how to use Google. And if you can't find it, ask me and I'll Google it for you. All right, so then your client code will create a sphere and a cube and print their volumes and surface areas. Does that make sense? At least this one has them behaving differently. This one should take you no time at all. The other one, where we had a rectangle and, excuse me, where we had a block in the cube, right? Because all we were doing is providing a custom constructor. The cube had no additional behavior. Here, these two shapes do have additional behavior. The cube has a different get volume and get surface area than the circle one. Still pretty short, but this is going to be more similar to our example today. Actually, our example today covers both, right? It covers custom constructors and it covers overriding methods. Hope that makes sense. I'll type this up as a good homework assignment. Are we good on this one? All right. Okay. If you're behind on homework, it's not too late to catch up. Please catch up and then ace the exam. That's all.